Hello there, I'm Thomas Hatsios, I'm American pilot flying the Boeing 787-900 tonight flight from Zurich International Airport. Gonna be overflying Zurich, Switzerland, Germany, then coming back to the Zurich International Airport. Runway 1449, Ilsloc, landing Suriname in the cockpit for the pre-takeoff preparation of the quality wings Boeing 787-900 and Microsoft Flight Simulator X. I'm going to start showing the cockpit instruments, displays, and the functions of the Boeing 787-900Z aircraft. I'm going to start with the primary flight display that displays the airspeed indicator, the airspeed selected from the autopilot, the flight director system panel, the ground speed, the radio altitude above the ground level, the barometric altitude above the sea level, the target altitude selected from the autopilot flight director system panel, the barometric pressure of the outside atmosphere, the vertical rate of climb, the descent of the aircraft intends hundreds and thousands of feet per minute, or the steepness of the trigonometric angles in degrees can climb and descend. We have also the attitude indicator with the pitch ladder degrees, the bank angle degrees, and the artificial horizon. We have the ILS localizer, the horizontal localizer, vertical glide slope for the terminal navigation to the airport runway. We use the magnetic northward heading runway, and this receives the frequency from the runway antennas, so it aligns the aircraft with the runway in horizontal vertical profile. We have also the ILS localizer curve dash, the flight director curve dash for manual guidance of the aircraft, and the autopilot curve dash for automatic guidance of the aircraft. We have also the angle of attack of the aircraft as it flies, and the flight mode and zero, the autopilot and the autothrottle, lateral and vertical navigation modes. We have also the HSI, the horizontal situation indicator, with the standby. You can see here the integrated display of the flight plan over here. You can see from takeoff over here we have the runway, takeoff, climb, cruise over here. We make a circle, then descend, approach, and landing to the airport. So this is the complete flight plan. You can see with the purple or magenta color over here, also the line that displays the target altitude. Right now we're gonna change that later. So you can see the horizontal over here and the vertical. You can see the airspeed here right now, the indicator, the barometric altitude above the sea level, the target airspeed and the target altitude, the pitch ladder in degrees and the bank angle in degrees, the radio altitude above the ground. So I'm gonna show you all the things we need to know before going into flight. We're gonna make an engine start demonstration and then make a complete flight from takeoff, climb, cruise, descent, approach, and landing. So I will show you all the primary flight display, flight mode on zero, with the autopilot and the autothrottle, lateral and vertical navigation modes. We have also the total HSI and the navigation display. We have the magnetic heading and track, the magnetic north pole and true north pole, the magnetic variation. Depending on where we are in the world, we have the terrain and weather reflections from the terrain weather. You can see the terrain map displayed with the GPS, also the airports, the waypoints, which are horizontal vertical navigation fixes the aircraft will have to transverse through. During its flight, we select some using the flight management computer when I create the flight plan. Using the seats, the start arrangement departures, and the stars are determining arrival waypoints and fixes. So I created a flight plan, a small flight plan for a small flight from takeoff, climb, cruise, approach, and landing, using the flight management computer over here. So you can see now the legs of the flight plan, which from takeoff over here, climb, then we have the cruise over here, next page, flight level 25,300 through the Nigra Matic, then descent over here, Amiki Zui ZH701 TRA over here 185,000 feet. Then we have the terminal approach, the stars is the other terminal, arrival waypoints and fixes here in the flight management computer. Runway 14, 140 knots, the airspeed at touchdown, and the barometric altitude. So you can see all these waypoints we have to transverse through. They're depicted here also. So you can see from takeoff, I'm gonna show you, we have the runway here displayed. So we're gonna climb through, then cruise. You can see also the vertical profile. You can see also the terrain in the vertical when we're gonna be flying, how far above we are from the ground. Also around us we have some mountains to avoid. So I used the flight management computer and created a flight plan or a flight path or a route for this aircraft using all the data the aircraft needs for this flight. So the navigation display also displays the terrain and weather reflections from the weather radar, terrain map, the airports, the boards, the ADFs, the navigation aids, board station ADFs and DBs, the waypoints. We have also the display of other aircraft that fly around our own aircraft using the transporter, the DSP and ADS transmitter receiver that transmits our frequency to other aircraft, and the air traffic controls also receives from other aircraft, and it makes a calculation using the radio frequency difference. When the aircraft is flying between our aircraft and the other, you can calculate the distance of the other aircraft, where they are located, the altitude difference, how many feet are above or below our aircraft, where do they climb or descend with respect to our aircraft, and also the velocity closing in. So if there is an aircraft that is coming close to us, like 3 nautical miles, it's going to give us a warning. Using the TICA system, the traffic collision advisory system, will give us a warning to make a collision avoidance maneuver in flight. So we're gonna have also so you can see the diamond shape of the other aircraft when we fly or when we are in the ground, also displayed in the runway and taxiway. We have also so this is the main components. We have also I use the flight management computer, as I told you. I use the performance page. I will show you the takeoff gross weight of the aircraft. That includes the empty weight plus the passenger plus the cargo plus the fuel on board, where the cargo and the fuel are stored. Let's say the fuel in the left and the right wing, in the center tank, left and right wing, fuel tank, center tank. The flight management computer is going to calculate the center of gravity of the aircraft for flight automatically every second. Also, when we fly, we burn fuel, so the center of gravity has been saved in flight. It is recalculated every moment using the flight management computer. So we have also using the flight management computer, I input this data. The flight management computer is going to calculate also the minor dynamic chord position of the forward wings. Is the position where the maximum aerodynamic lift occurs in the forward wings. Is the position where the center of gravity has been calculated using the minor aerodynamic chord, the Mach 33% for this flight of the chord of the forward wings. Is the position where the center of pressure of the top surface of the wings is calculated. Also is the position where the airflow of the air mass becomes detached from the top surface of the wings when we fly for a given angle of attack, and on airspeed that is changing in flight depending on configuration and altitude and other factors. So for a given angle of attack, when we have full flaps, for instance, we are close to the runway after takeoff. That is like 120 knots is the stall speed. We need to avoid it. So you can see here, I will talk to you about aeronautical and aerospace engineering, how to use the aircraft aerospace and aeronautical engineering principles for the air transport pilot license. So we need to know these are the wings of the aircraft that hold the weight of the aircraft as we fly. You can see we have the mean aerodynamic chord position. The Mach is about 33% of the chord of the wings is pretty much here. It's where the maximum aerodynamic lift occurs in the wings, where the stall also will begin for a given angle of attack. When we fly, you can see also where we calculate the center of pressure behind the center of gravity over here. So we have the longitudinal axis, the vertical axis through the center of gravity, the lateral axis from wingtip to wingtip, the thrust vectors from the engines. We propulse the aircraft forward. So the lift is being generated by the airflow below and above the wings. Also, we have the deflection of the flight controls surfaces. I will show you the flight controls in a couple of minutes, how to use them. So we can also trim the horizontal tail using this component. Trim up and trim down the horizontal tail I will talk to you about now. Also the rudder, we can change direction, also the elevator, climb, descent when we fly. So you can see the tops, you can see the bottom surface of the wings is more flat. As we fly, the airflow is moving slower using the Bernoulli theory of fluids from physics, so there is higher pressure below the wings, which pressurizes the aircraft weight up into the air. Also, the top surface of the wings is more curved, so the airflow is moving much faster above the wings. So this makes a lower air pressure, which sucks the aircraft weight and wings up into the air when we reach the takeoff speed. So we use also deflections from the wings like this. So also the flight controls. I talked to you about the trimming the horizontal tail in flight. This is done either manually using the horizontal trim stabilizer over here, trim switches. We can trim the horizontal tail of the aircraft like this, trim up like this, or trim down the other way. When we're doing this way, trim down. When we do the other way, trim up. So the same is displayed here. So this makes the tail of the aircraft over here moving either up or down in flight, like this, the whole surface. So it will reach the degrees we have selected, so it will balance the aircraft through the thrust from the engines and the center of gravity in the wings, the forward wings. So you can trim nose down or nose up. You can relieve also the pressures from the yoke when you fly by trimming the horizontal tail of the aircraft. So we have the horizontal trim stabilizer. I'll start talking about the components. The horizontal trim stabilizer position in degrees over here displayed. Also we have another page. We have the rudder trim also over here displayed. The flaps position, flaps and slats, which also flight controls. So you can see we have also the alternate over here pitch trim. So we can trim down or up like this. The horizontal tail again. So this trims again the horizontal tail of the aircraft. Up and down, the left and the right, so you can trim up and trim down in flight by moving these small switches. We have also the parking brakes here displayed on and off. We have the stabilizer trim. You see this guarded switch. We have the cutout switch. So this is for all Boeing aircraft: 737, 747, 757, 767, 777. We have a failure of L2 or R2 hydraulic systems here. We can have a malfunction of the autopilot and flight director auto trim functions, and this is having an auto trim function using when we use the autopilot and the auto throttle. It trims the aircraft automatically. So we're gonna have a failure of that. We need to come down here and disconnect from normal to cut off. Open the guarded switch from normal to cut off. I'm gonna use the alternate maybe, but the normal is for sure. We're gonna use the normal trim switch like this, trim up and trim down. We have all the time normal trim function, so which is manual. So I'm gonna show you also the rest of the flight controls. Climb, descend, the horizontal tail, make turns left and right, right and left like this, right, left. Using the control column, the rudder pedals. So I will show you we have also the flaps here, which increase the surface area of the wings. You can retract like this the flaps or extend. You can see how many degrees we have extended right now: 30 degrees, 35, 30, 5, 10 over here, 1 degree. We have also the speed brakes over here. I believe it has more positions in real, and that maybe has flight also in an arm position, but doesn't display right now over here. So we see the flaps, unless it is automated in the 787. So we have the flaps over here. You can see the flaps are deployed left and right wing, increase the surface area. Also the speed brakes here. we can extend at any moment. It's also used as for turning the aircraft in flight. So this is this handle over here, what it's doing, extend and retract. So this is for landing. We extend fully to slow down the aircraft during a landing, touchdown or a rejected takeoff. Perhaps in the air there is a less deflection than the flight dead end. So we have also so I will show you now the rest of the flight controls. The autopilot flight director system panel, the thrust levers. So maybe I will continue now with the flight controls. Here I will show you also the Lszh. I will show you the Lszh Extreme 3D joystick I use for the flight simulator, Microsoft Flight Simulator. So I have the yoke, the control column to move the horizontal tail, the elevator section up or down for climb or descend the aircraft in flight. I can make also bangles left and right using the control wheel. Also to use the rudder pedals to make joint turns in the air using the rudder, the vertical tail of the aircraft section. I have also interconnected in the ground the nose wheel steering, which is interconnected with the tiller, so I can use the nose wheel of the aircraft for making left and right turns. Also the rudder pedals, toe brakes. I have also the thrust levers, the horizontal trim stabilizer, the flaps and the slats, the speed brakes. So I have all the flight controls of the aircraft in flight. So I can apply also the thrust from the engines. So I will start showing you now the flight control systems. I will show you also the outside view of doing the same thing using the flight control system. So you can see here we have, I don't know, maybe the lighting is not so much. We have better lighting like this. So you can see we have the side stick. I can climb and I can descend like this. Over here we can make turns to the left and turns to the right, as you can see. Hope you like the side stick, how I use it. So climb, descend, make turns to the right, make turns to the left. We can use either surface, only the column, elevator, climb, descend, only turn left and right, and the rudder pedals, or only rudder pedals if we need. So I have the horizontal trim stabilizer over here, the trim switch, the flaps. I have also the thrust levers over here. So I will show you how to use the thrust levers, the engines control here. So you can use the thrust from the engines like this. You will see the thrust increase over here in the panel, on the display over here. You can see the engine change its thrust and rotation pressures and fuel flow. I'll talk to you about also. They're gonna make a complete flight from takeoff, climb, cruise, descent, approach, and landing. Maybe I'll say this view also is very nice. All the flight controls. So we can make climb, turn. So climb, descent, make turns right and make turns left like this, just like in the Airbus aircraft it was. Use also the rudder pedals. Here we have the trim over here. So hope you like also the thrust over here, the thrust levers when you apply. So you can see the captain and the first officer are interconnected in flight and move together. The side stick deflection, is proportional to the yoke deflection, like this. Climb or descend, make turns. Side stick deflection proportional to the yoke also. They are interconnected, move together, and unless we have a failure, and not like in the Airbus where we have side stick priorities. So you can see also the outside view over here, again for using the flight controls, like this. So you can see we can climb, we can descend, make turns. This is the climb. Also make turns again with ailerons and spoilers. So this is, I believe, all the flight controls we need to know right now about the Boeing 787. All the flight control surfaces like this. So now we go to the rest of the systems. So I'll talk to you about the horizontal trim stabilizer. You can see the column here moving up and down. We have the thrust control. You can see the autopilot flight director system panel over here. So we have the autopilot flight director system panel. We have the autopilot engage and disengage switches. The auto throttle over here, left and right. The arm and disarm, you can see auto throttle being displayed. Autopilot, autopilot disengage, flight level change, LNAV, vertical and LNAV, lateral navigation and vertical navigation, climb continues, and auto throttle. So we have the flight director on and off. Over here we arm this and turn off the flight director like this. This disarms the modes. We need to arm it again. We have also the airspeed here. So this is the airspeed guidance. As you can see, climb continues, auto throttle, flight level change, vertical and lateral navigation for flight director, autopilot, disengage, engage, disengage over here. We have also the bank angle, the heading. You can see heading selector, mode control. So we have the bank angle here, limit for flight, the hold. So we're gonna use the magnetic North Pole heading for this flight, 136 degrees. We have also the altitude here. We're gonna select like 25,300. The hold, we have the roll localizer, the approach for autoland, the vertical rate of climb descent over here, vertical speed, FPA mode engage, vertical speed selector. So if we select this, we can see the 0. We can select a descent using the minus, the throttle, or a climb the other way. You see how fast it changes, like 12,500 feet per minute. You can see the airports here around us in the distance, the names of the airports. So now we have the airspeed here selected, the airspeed indicated, the altitude, target altitude, the barometric altitude above the sea level, radio altitude, the pitch ladder decrease 2.5, 5, 7.5, 10 degrees of pitch up or pitch down altitude, the bank angle decrease, The vertical rate of climb distance of the aircraft 10,000 feet per minute, so you need to pay attention when you have a positive pitch altitude in flight. The aircraft might be either climbing or descending, so you might be falling, so you need to pay attention to both, and also the airspeed all the time. So you can see also the same things here are displayed, the airspeed indicator, barometric altitude. So we have a few more things pay attention to. The barometric pressure setting also here to the 9.92 right now. Over here is select from the FS panel. We have the system display here also, I will show you later. So we have here the standby display, some messages. This is the multifunction display that displays the engine's indications. You can see the left versus the right engine, what it displays. We have the N1, which is the low speed start and stop, the low pressure compressor and turbine of the turbofan, which is engine left and right, the exhaust gas temperature per engine. The N2, which is the high speed starter and stop, the high pressure compressor and turbine of the turbofan, the turbos engine the left and the right, the fuel flow per engine per 1000 kilograms, 1000 pounds, oil pressure, oil temperature, oil quantity, oil quantity, and the vibration of the N2 stages of the engine. So we have the gross weight 357,900 pounds, 1000 pounds total fuel on board, 35,000 pounds saturated air temperature, fuel temperature. We need to heat the fuel all the time during flight. We have the landing altitude, the landing gear over here, extend or retract, the alternate gear, lock override here, the auto brake or rejected takeoff. In flight also we have, you can see the auto brake display here. When you use, we have a disarm, auto brake 1, or rejected takeoff RTO. So we disarm it, maximum auto. So we have a few more things. I told you speed brakes, flaps, thrust control. We have the auto throttle. Here it's the left and the right engine, auto throttle. Disconnect switch over here, takeoff go around switch over here. So this disconnects the auto throttle. This is takeoff go around, the thrust reverse. When you move the thrust levers, you'll see the thrust indications as I saw you, all controlled by the pharex. Change, you can see the requested versus the actual. It takes a few seconds for the engines to spool up or spool down. In flight you need to display that. We have the fuel flow from the left and the right engine, because this is the left and right thrust control, the left and right engine. Fuel control and cut off. We have also the fire extinguishers for the left and the right engine. We pull out and switch. We have the transporter here, the radio communication panel, the radar trim over here. So then I'm gonna show you the overhead panel. I'm gonna show you the electrical. Here we have the APU. We're gonna start. We need the APU to start the engines, the auxiliary power unit, a smaller turbine in the tail of the aircraft to start our engines. You can see also here we have the primary flight control computers. We have the flight control surfaces, the air data computer with the heading reference, left and right inertial reference system. So this is inertial reference alignment using laser gyroscopes, the 3 GPS, 2 or 3 GPS receivers, the magnetic north pole and the true north pole. We have all the air data, pitot, static and pitot, dynamic, the angle of attack of the aircraft as it flies, radio altitude, laser gyroscopic precession and deceleration in flight from the altitude indicators. So all these air data you see here displayed, the airspeed, altitude difference when you climb, descend, altitude in flight, pitch or vertical rate of climb, descent, radio altitude, GPS position, magnetic north pole. So these are displayed using the air data computer over here. It's our control from that. Then you need to align also. We use the flight management computer here for alignment, the GPS position. So I show you how to use the flight management computer. We have the initialize, route, display, origin, departure, destination, runway, select 14, departures, the seats, standard instrument departure, waypoints and fixes, arrival, over here, standard terminal arrival, waypoints and fixes, with this ILS localizer runway. So this departure arrivals creates a small flight plan from takeoff. Over here, climb, cruise, then descend, approach and landing over here to this runway, 14 over here. So we have the gross weight, the index here, what we can do with the flight management computer. You can see ident, position, performance, takeoff, approach, flight plans. So we have the position here, reference airport, last position, GPS position. So initialize route, the takeoff gross weight, the performance over here, cruising altitude, fuel cruise, minimum fuel temperature below which the fuel freeze, center of gravity in flight. So zero fuel weight plus fuel on board, we have the gross weight for flight. The reserves also 5%. The index. This gives us also the takeoff here. We're gonna use 15 degrees of flaps, center of gravity with a trim stabilizer 4.25 degrees for this runway length and runway slope. The takeoff speeds V1, V rotate and V2 for this gross weight. So this is other flight plan we have created over here. So I use, as I told you, takeoff gross weight, mean aerodynamic core position, left and right wing, center tank, fuel on board, center of gravity, horizontal trim stabilizer. The flight management computer is going to calculate the length of the runway. We have the Zurich International Airport, the Lszh and runway 14. So we are located in the Zurich International Airport, Lszh and runway 14. We're going to use for both for takeoff and for landing. We have the runway length, runway slope, the wind direction and speed, barometric altitude, the density of the air, the temperature of the air, the runway conditions, if it is ice, dry or wet, and we have the takeoff speeds. For these flap settings we use 15 degrees of flaps, and this give us takeoff speeds V1, V rotate and V2. Also we have the V2 plus 15 knots, which is the takeoff climb speed. Then we have the seats, the standard instrument departure, waypoints and fixes for the initial climb of the aircraft, horizontal vertical navigation fixes and altitude and speed constraints. The climb to the cruise level like 25,000 or higher, 26, 27, 28, 29, 30,000 feet. For this flight we can also have the cruise level, intermediate waypoints, and we have the top of descent. We're gonna descend back to the airport elevation, close like 6 or 5,000 feet above the sea level. We have the stars, the southern terminal arrival waypoints and fixes that include horizontal vertical navigation fixes for the terminal arrival to the airport. The long final, the short final is gonna align the aircraft with the runway heading. We have also the ILS localizer, which we tune automatically when we select using the flight management computer. The ILS localizer, which are the antennas that transmit radio frequencies from the runway threshold all the way over to the aircraft, as we are trying to align with the horizontal localizer and the vertical glide slope for aligning with the runway magnetic. We're going to use the magnetic north pole heading of 136 degrees for the runway 14 of Lszh Zurich International Airport. So we're going to be aligned with using the ILS localizer, the instrument landing system of the airport. We're going to approach and land. We're going to use like less than 9 degrees of pitch altitude in flight and like 150, 160 knots or higher airspeed for touchdown, and about 35 or 30 degrees of flap. So you're going to see what we're going to do for approach and landing. I'm going to show you the complete flight from takeoff, flight, cruises and approach and landing. I'm going to show you also the thrust, the engines indications. We have the engines, the GNX engines installed on Boeing 787-900 aircraft, one in the left wing, one in the right wing for symmetrical thrust and redundancies, one contains a gearbox of the Hatsios. The Hatsios are the flow for these electronic control computers, one installed for forensic gearbox, dual tunnel redundancy, one tunnel face, the other takes over, controls most of the display. All the NZ data you see in the upper and lower ACAS and sensitization controller system display, all the multifunction display, like the N1, which is low speed solid soft, low pressure compressor, turbine with the two front with the NZ details, cost temperature ranging. The N2, which is the high speed solid soft, the high pressure compressor, and turbine of the turbo fan, which is anything the fuel flow per inch per 1000 kilograms pounds, solid pressure, or temperature, quantity, and vibration of the two states of the engine. The Phalanx also control, as we're gonna see here, we have the pressurization system in the overhead panel. So we're gonna turn on from auto to manual the pressurization here. Valves, it's gonna display over here. Cabin altitude, rate of climb descent, differential pressure, landing altitude, the outflow valves position. So besides the engine data, you see also the cabin pressurization. So the Phalanx control also the pressure inside the engine, so we have an overpressure and under pressure, so you can open and close the outflow valves to the higher lower pressure position to label, decrease or increase the pressure. Also the control the 5th and 9th states outflow valves from the compressor starters section. Also the bypasser from the front fan. So we have pressurizer for cabin pressurization, wing and engine RDIs. We need pressurizer for all these things from the engines or from the APU. Wing and engine RDIs, cabin pressurization, air conditioning, ventilation, oxygen regulation in the cabin cockpit. Also for hydraulic fluid pressurization, we need hydraulic fluid pressurization tanks, hydraulic fluid tanks to be pressurized using pressurizer from the engines or from the APU. So all the flight controls, you see here I move using the yoke of the Boeing 787, the column and the rudder pedals, the nose wheel steering. So is the elevator, the tail, the vertical tail, the ailerons and the spoilers here, the flaps and the slats, so the flight controls. The landing gear extender retract, parking brakes, auto brakes, flaps, speed brakes, thrust reversers for the engines, nose wheel steering. So we have many systems. The horizontal trim stabilizer that use the tiller here, the nose wheel steering. We need the hydraulic fluid pressurization. We also have pressurizer from the APU. I'm gonna show you. We're gonna start the engine. I'm gonna start them down in 7. I'm gonna show you how to use the APU to start the engines. So we're gonna have all these things. We have a few more things to do before flight. So the Phalanx control all these things, outflow air from the United States. Also fuel metering unit, fuel flow to the engines, engine start, engine shutdown, engine failures, fuel heat exchange sensors and oil heat exchange sensors. We have to heat the fuel and the oil using the circulation from the wing, left and right wing and the center tank into the engine's components which ducts heat from the engine components into the fuel to cool down the engine components and also to heat up the fuel, so we will avoid freezing like minus 37 degrees. In flight we have the fuel on board will freeze, also the oil will freeze. We do the same thing. Recirculation system for which is also automatic. So also we have, as we fly the aircraft, as we climb from the sea level all the way up like 30 or 40,000 feet above the sea level, like 9,000, 10,000, 11,000, 12,000 meters above the sea. As we climb higher, the air, the pressure of the air, the oxygen level, the pressure of the oxygen and the density of the air become less than half than that of the sea level. Also the aircraft we're gonna fly with an airspeed rate like 2 or 3 times faster than that of the sea level. The temperature of the air is becoming freezing like minus 30, minus 40, minus 50, minus 60 degrees below zero. So as the aircraft flies faster, 2 or 3 times faster than that of the sea level, we have a higher inflow of air from the front fans stage into the engine for compression and fuel mixture. So as we fly the aircraft, we need to adjust the fuel mixture at this moment. This is done also automatically using the Phalanx as we change altitude then as we descend back for the airport landing elevation. So it's a good thing to have the Flught installed into your engine. So I will show you now the overhead panel systems and the displays here in the digital format of the displays. You can see we have the controllers, left and right engine IDG, the gray dry generator, 120 200 volts frequency, 400 frequency alternate current, direct current from the batteries 48 ampere hours. So this is 120,000 kilovolts each one. External power, we have the primary flight control computers in the auto position, air data computers here, flight control surfaces, some other systems, exit door, battery town. Over here we have the window heat, rammer turbine, hydraulic fluid pressurization here. We turn the primary and the demand, which are pressurized by the engine. We have the electric also. So you see what happens. We have the Ford display. We turn back in the current position, then to the auto. So we have also wing and engine guard the eyes over here, like this, on or auto. We have also the lighting system and the windshield wipers. We have over here the cargo, fire, and the APU fire, some other systems over here on the top. We have the electronic engine control for the engines, left and right engine. The auto start here. So we're gonna auto start the engines like this. We have also the pressurizer from the left and the right engine, the cabin pressurization system. Also we have we can arm this and dump some fuel in flight, select the nozzles and how much fuel to remain. We have also the fuel booster pump, the left and right wing fuel tank, center tank. We can off the crossfeed valve can feed either tank, either engine with either tank or either pump. So we need the fuel booster pumps on. The balance also we don't need right now. So we have the cabin pressurization over here. In the manual we use the outflow valves when cloud descent to pressurize the aircraft. So we use the auto position, so we don't have to do. Now you see all the displays here, the diagrams of all the systems, electric, hydraulic, fuel and pressurized air. You're gonna see them in a digital format here display. So we have the systems display over here. You can see we have the APU is running, hydraulics, oxygen, liquid cooling, displays all the information we need to know. We have the left and right IDZ, the gray dry generator from the electric panel here, as you can see now in digital format here. The Lszh main battery 31 and APU battery 33 volts. The APU generator also is running. The hydraulic fluid, where the hydraulic fluid goes, which system uses it. Also the pressure of 5100 psi, it's left and right engines, C1 and C2 electric. The hydraulic fluid quantity, shut-off valves and primary in demand. The fuel, we can have the left and right wing fuel tank, the center tank, the fuel booster pumps forward and aft are all running. You can see the low and high pressure fuel valves here are open and feed both left and right engine. How much total fuel we have? 34,300 pounds, 11,000 in the left wing, 11,000 in the right wing, and 11,900 in the center tank. The crossfeed valve is off, but if we turn it on, you can feed either engine with either pump or either tank. The APU is fed from the left wing using the DC motor. Also we have the minimum fuel temperature down here, below which the fuel will freeze. So you can see minus 37 degrees minimum fuel temperature, and the fuel temperature right now. So we have the circulation to the engines, which heats up the fuel and the oil in flight to avoid freezing. The air pressurizer, left and right engine, APU, all systems. Doors are closed over here. The cabin can be pressurized, the gear, the temperature of the brakes, and the pressure of the tires, the flight controls. So this is the flight controls here. We can climb, descend, make turns right and left over here. So you see all the flight controls are moving. You can see the tail over here, also the limits when climb, descend, the rudder, horizontal trim stabilizer. So this is very important. The FS display, maintenance over here, system display again, so maintenance and circuit breakers. So we have the last thing here, the checklist, like normal resets and normal menu before before start, before takeoff, after takeoff, descent, approach, loading. So you see now the navigation display. So this is the last thing. Now we're gonna start the engines. I'm gonna shut them down and restart the engines very quickly. So we're gonna make a complete flight now. So we use the outflow valves both to the off like this. You'll see the engines will start down. Also we need some lighting. So you will see now the engines are starving down because we have no fuel flow. So this will stop both engines over here. You can see the hydraulics are off. Now we need to restart both left and right engine to the on position using the auto start. So we have the auto start now kicking in. So you will see the exhaust gas temperature. The N2 also increases. So when we have an N2, you can see now we have pressurizer, the left and the right engine. Now we have a pressurizer. We can let the fuel flow here. Fuel control on both left and right engine. Also close this wooden need. So we have the auto start now is kicking in. So you can see auto start here. Left and right engine auto start. Now you're gonna see all the systems coming up again, back to life. So this turns off the warnings, auto start. We need a couple of seconds more. We're gonna have running engines now. So this is how the running, both engines, left and right. So we use flaps now for takeoff, and we proceed for the takeoff over here. So we advance the thrust levers forward. We take clearance from the air traffic control here. So the runway is open for us. Some parking brakes and align with the runway heading. So we are aligned here for takeoff, as you can see. So we use takeoff power like this over here. So we have full takeoff. So we have V1, we rotate rotate the aircraft slightly, like 9 degrees, no more, because it will give us a tail strike. So we climb, we have positive rate of climb, but we can hand fly hands off like this, you can see, because we are so much well trimmed. So landing gear up, retract landing gear. You can see all the indications right now. The airspeed, we are 1,700 feet above the ground. The altitude 3,000 feet above, 2,200, 300 above the ground, 3,900 above the sea. The airspeed, we need to pitch down. The pitch altitude is less than 20 degrees right now. We have the horizontal here and the vertical. You can see the ground here below us. The engine's indications also as we keep climbing. So gonna see also here we change the view. We look further, you will see the red and green and yellow indications from the terrain over here. Also below the altitude, how far away we are above terrain. So we're gonna have the flight plan where we are right now as we climb. We have a very nice view over here of the Switzerland. We're gonna start the turn now. So in order to start the turn, we're gonna make a small turn like this. As you can see, is also the rudder, left rudder, and the control wheel together. We can leave our hands off again. The aircraft will stay in the air. As you can see, hands off, because we are very well trimmed right now. It won't go full. So you can see here, we're climbing. We have 16 more minutes for this flight. We can see now the airspeed versus the stall speed here. Airspeed and stall speed, 120 knots with yellow and red. Below the airspeed, 11,000. The altitude we keep climbing. So maybe we need to start retracting the flaps. Make another turn here. So you can see the displays, the navigation again. Format, we need the flight one. So maybe we retract some flaps and leveling off to increase the airspeed. It's a bit helpful. So we have the view of the cockpit inside after takeoff. All the indications here, engine fast. So we have 13 more minutes left for this flight. So we have a very nice view over here around Switzerland. So we need to align now with the waypoints here. Also increase the airspeed. We're gonna level off for a while. So retract all the flaps and give us higher airspeed rate. So now we are accelerating. And also climb. So this is a very fast acceleration now taking place to avoid also the stall margin. So now we fly with the selected airspeed. We're gonna be flying a bit higher airspeed than God. So we have again a nice view. We have the lake. We have the Germany, my homeland, the Bayern Munich here. This the France, the Galaxy also, and the Switzerland. A very nice view. The Swiss Alps. This beautiful lake. The Germany again, Bayern Munich. So the France over here. So we have 10 more minutes left for this flight. Very beautiful view. I'm gonna start now turn. So it's the altitude we'll be flying to, cruise altitude. Gonna be having also the handrails over here. So we have 10 more minutes. We need to start the turn now. Over here. So we turn slightly. We have 10 more minutes for this flight. So we have also the vapors, the frozen vapors here created in this altitude. So we need to turn, make a steeper turn now. Gonna level off also. So make a right turn using the rudder pedal, also right rudder, and the control will rise. So we can fly right now, as you can see. Add some more thrust now. So this is the complete turn. Over here we keep flying manually, as you can see. So we have 7 more minutes. We need to start now descending. As you can see, I'm gonna start our descent. So we have this beautiful view over here. The frozen vapors. So fast to idle and start our descent. So use some speed brakes to increase the rate of descent. Pitch altitude down. So we keep having 36,000 feet over here. A beautiful view. So we need to come closer to the airport, and we have 6 more minutes to go. So we add some airspeed like this. Idle thrust again, do more idle thrust. So we have the runway here, and we have 5 more minutes left for this flight. So 4 more minutes. We'll start that turn in a couple of minutes like this. Slow down a little bit the aircraft. So we need to start the turn now to the airport direction like this. So here we are. And we have 3 more minutes to land the aircraft. We need to align with this line here. Landing gear also down, flaps start to retract. So we have 2 more minutes left for this flight, and we are aligned almost with the runway. Over here. So we have 1 more minute, another maneuver now, to align again, right there now. So you can see we have the ILS localizer also with information we need to fly the aircraft. So we are in alignment with the runway again. So we have a few more seconds. Over here, align. We have also a little bit more thrust. We're going for the flare over here. Align. I'm gonna have the flare. So here we are, just touch down. Idle thrust, parking brakes, and thrust reverses. So we're slowing down, align with the right rudder and left rudder when we need the runway heading. So here we are, just slowing down the aircraft in the runway. Very beautiful. Touchdown. Left rudder now. And right rudder. So you can see all landing